This is IBM Museum, and I wanted to start up a Model 25 that I had in a live stream a couple weekends ago. It wasn't the Model 25 that I had in this last weekend stream, but some people may have noticed a particular aspect. I even made a comment on it. And I'll go through and actually get myself off the screen just so we don't have that phase thing going on. And I can switch over at the appropriate point here. I'm still going through and rearranging a little bit of the bench and the layout here, getting monitors moved around, but it's a pretty good setup for now. Okay, and that's not probably very visible. At least I've got this Model 25. You see that white cable coming out the back. This actually has the ability for external video. I've added on a module. I'll go through and talk about that module in a later video. But we can go through and get the video capture turned on. I'll get myself back on the screen so you can see my back at least. You'll notice here that it goes through and it loads the AST clock. And that's a driver for the Six-Pack, plus it's on this Model 25. And it is version 1.21. And you'll notice there that the current date marks it as the March, 03/15, March 15th of 99. And theoretically meaning 1999. And then it has the current time. And otherwise, besides the year, that information is correct. Now, in reality, we'll just do a date. The D on this is really, it makes it so an 8, not date. But we can see here that the actual date that the computer thinks it is, it's retrieving that value from the real-time clock chip on that AST board. It understands it's 2022. And so it's just a matter of how the AST clock program displays that year, not in effect of the year that's set on that real-time clock. And there was a topic. I'll go through and I'm going to get my browser capture up. And I'm enough off of hiding anything that would be on the page. But there was a recent topic that was revived. This is originally posted, more than 4 years ago, in March 8th of 2018, but it was recently revived, just about exactly 4 years later for the topics. And I'll get to where I can interact a little bit with it. But somebody goes through and they talk about in this, and I'll have to get to where I can read this a little bit better. I don't have well, maybe I can go through and get glasses on and kind of look down my nose without too many reflections of light going on. But it says, hi, I bought my first IBM PC 2 weeks ago and got it all working except for ASTCLOCK. Y2K was really bothering me, even though it was only visual. And it gives a link to a later topic. I decided to work on the Forever/99 year issue with ASTCLOCK. And what the reference is it's just a matter of how ASTCLOCK displays that year, not the actual year that's in effect on the real-time clock. This is my first disassembly reverse engineering project, so feel free to share your comments and or concerns. And it just happens to be, I mean, AST released a lot of those 6-pack, plus they had some other adapters as well for the IBM XT class machines that had real-time clocks and had different IO functions, parallel ports, serial ports, game ports, and that's all the different functions. That's why they called it a 6-pack, is that it, supposedly for the 6-pack adapter, it had 6 functions that it added to the PC. One of those was also RAM, more memory. And they included drivers for the real-time clock and using that memory, working with it on the XT class systems. But so it's just identified here as the 6-pack plus, even though that covers other ASTCLOCK implementations, and talks about the patched version 1.0, 1982, no version number. And then it has an attachment. It has a zipped up executable of that program, of the patch program, and also talks about the patched version 1.21, the newest, and that's the version that I have on this Mall 25. And it's got that zipped up in a file that you could download from the internet. And I just, if you know the Mall 25, in fact, I don't know for this one. I think I tried to work with it a little bit, but let's go through and get that down off the screen for now and actually get where we can switch over to so if you notice this, I mean, I've got the Mall 25, I've got the 720 KB drive, and it does have on this particular model, I have the 4869-001 adapter on this, so I could use the external drive, that 360 KB drive. But, we're talking, I've got like Windows 10 here for my recording system on the internet. I mean, I could go through and I could get my tweener system over here on the side started up. And that gives me, I probably have a 720 KB diskette around, but this 720 KB diskette drive, I think, was giving me some issues. And when I went through and tested it, I've got to go through and check a little bit more. And it doesn't report any errors on startup, but I think the ability to read diskettes is just, it's shot. I've got to go through and work with it. And that certainly for that 360 KB external drive, it does 5 1/4. So I don't have a modern machine that does 5 1/4 inch diskettes. So how do I get that file onto the Mall 25? Well, I didn't happen to see this particular portion until a little bit later on in get to where I can interact with the page. I'll get back up on screen this way, keeping my glasses on so I can read if I have to. And it talks about, of course, the warnings there. And I'll go through and accent those warnings. They talk about backing up the ASTCLOCK program. You don't want to go through and have a working copy of your ASTCLOCK program and go through and modify it, and that modification doesn't work. And so they talk about making a backup of it. And I'll go through and actually, as I'll show from the method where I'll modify the file and have it under a different name, and then go through and come up with a backup after this process. We're not working with that particular file, so we should be good. And it's even interesting for all that. I mean, the topic, and that's great that for whoever offered this. I've heard of other people talking about this in the past, and I know that there was patches that were out there that worked with going through and correcting this issue, or even modifying the file and coming up with a different version that displayed the date a little bit better. But after this, there's even a point to where the they talk about replacing the bytes, but then they go through and, well, if you don't have those bytes in that particular location, your version could be different. And I want to accent a little bit more here that I know I have that version 1.21, and it's very defined on what I'm going to do to the file. But if you don't have that version, it's a different aspect. And I'll explain the points to this. Now, for the version, that ASTCLOCK version 1.00 that the author talks about here, the creator of this topic, that's the one that they're going through and modifying. And they do actually give debug code there. And that was going to be the topic of this video. Of course, I went through and, well, they just have the executable file that they included in attachments. They didn't show how to use debug to go through and modify the file in the case that you can't get that download onto the system that you need to patch. But they do go through and patch version 1, which has a different location for this particular area that is modified. And me having version 1.21, I'll show that process. And they do have there's some areas of shortcuts or not particularly explained as much that I can do as well. I can show how to modify that version 1.21 and go through and detail a little bit of the asides or the background to that as well in patching that version of the program. But I'm going to give a disclaimer as well that what you do is at your own risk. I'm going to demonstrate what works for me here. Not, if you choose to do this yourself, if you have the modification you're going to do, that's at your own risk. And I'll include the link to this topic at the Vintage Computer Federation, because it's nice for all the details. Let's get down to the point where below the debug, they, in this explanation, it just covers what particular code. And it actually, this author discovered that, hey, if you modify 2 bytes within the program, that's going to be for enough of a correction. And they go through and they talk about at the location for the version 1.00, here are the bytes and here's what you need to modify it to. And they have a disassembly, I guess, probably of that particular version. I didn't look. Certainly the address here, that 017A, is an earlier point than what it is in the later version. Now, the nice thing is down lower, or following up on other comments, there's also the talk of this is the change in 1.21. And that's the critical thing, because that's the version I want to modify. And it gives the address, and it talks about this. And I've got it all written down in notes. I have a way to reference it as I go through and do it as well. This is a change in 1.21 from that address at 02C6. There's the bytes of the B063, which means move AL the value of 63 and of course, debug always works in hexadecimal. And you need to change it to, at those particular 2 bytes at that location, as a subtract AL, or subtracting the value of 64 hex from the AL register. So you're effectively doing the same thing that they had encoded up above for the version, and they're going through and they're working with periods as the separators between the bytes, which is kind of a little bit more of a debug shorthand. I'm going to go through and write it all out, although you can go through and you can use these shortcuts. I'll show the same effective thing of going through where they're using the enter command and doing it all in one operation, one enter operation. And I'm going to show how to do it for each byte location. So we need to remember we've got that that 02C6 and 02C7 location, and that's where the bytes are that we're going to modify. And then even there's further talk of the topic. There's talk of a version 1.10 and going through and where the location is in that particular version of the program. And so, you know, that's great that just more people chipping in of talking about, and another, you know, person comments and says, hey, this is even modifications I did, increasing the size of that version 1.10 to display a 4-digit year version. So 2022, which would be nice, but I've got the version 1.21. It's the latest version of ASTCLOCK, and I don't have that earlier 1.10 version to patch, even though it'd be nice to have a 4-digit year and things like that. I guess AST probably went through and they had it as a 4-digit year at one point and then modified it down to a 2-digit year. But I mean, I think that the input there is great. They show all the additions that they're doing to that. And the aspect that I'm going to touch on shows really that file size is a critical aspect. And this will all be linked. I'll have this topic in the video description. But let's get around and get programming or debugging, patching the bytes on this AST clock. And so one of the things I want to do here is to go through first, and I want to do a directory of the AST clock. And we can even do just even a wildcard just to show, hey, what's all the AST clocks that we have there? And we have that AST clock of the 2,557 bytes. And we can see that date back in 1986, you know, maybe when it was copied or whatever else to the system. If we do, what I'm going to show here is I'm going to do a copy. We're going to take that ASTCLOCK.com, and we're also going to say ASTCLOCK.mod. This is the file that we're actually going to modify. Rather than making a backup at this point, I'm going through and creating a copy of that same file that just has a different extension. It has the mod extension. And so if we do a directory ASTCLOCK.wildcard, we've got that mod file on the system. They're the same size. They have the same date code stamp, even though I just basically created that file or copied that. It has the same attributes as that older file. And we're actually going to work on, in debug, we're going to work on the modified version that we just created. So debug space ASTCLOCK.mod. Now, normally when debug works, and especially with COM files, they have a 100-byte header, actually 100 hex header to that as debug goes through and loads that, even as it's loaded when it's executed on the system, it goes through and has a space before the COM file. And the exe files are different, but the COM file in this instance, that ASTCLOCK.com, has that stuff ahead of it. And so it, even in debug, when it loads it, I'm going to go through and I'm going to unassemble. And the thought is that it knows that this is a COM. Well, let's do this. We're going to specify, even though the default is that 100 hex byte offset. But this is effectively the start of the code of that AST clock driver. And I'm going to go through and just go through several unassembles. And you do unassemble, you just do U on its own line, and it knows what's displayed before. It just says the next block of data. And you can give it I've gone through on prior videos, I've showed that length command. You can go through and show a particular length of information for your dumping data or the unassemble command. I'm not attempting to be a debug primer in itself. I'm just showing, some of the basic commands to debug. And we're going to get down. Remember, we have version 1.21, and they're saying that area of code that we need to be concerned with is that 02C6. Now, it's important to note, if you were to do this on your own system, say you had a Mul 25, had that same version of AST clock and everything else, you went through and ran debug, you would have a different code segment than I would do. In other words, those first 4 digits, that 17DA, that's where debug is loading, has that code segment in this instance on the system. I could run debug at some other time. It depends on what I have loaded in memory or something else. That code segment could differ at that next instance that it runs. So the code segment here is in a sense, it's implied as I go through and I'm actually debugging the file. It understands where that code segment is, and I want to state that I implicitly know that, and I'm not changing that from what the system is working with. I just want people, if they do this for themselves, they're going to see some differences from how it is displayed on my screen. Now, the offset within the file itself is going to be the same. For version 1.21, it's going to be at that address of 02C6, and it's actually 2 bytes. So it'd be also the 02C7 address. There's 2 bytes, and we can see, and since it's the same opcode, we can see it on the screen here as that B063, meaning move AL, comma 63. Move the value of 63 hex into the AL register. And those are the 2 bytes that we need to modify. It shows the number of bytes in that for whatever opcode in that column after the address. So we have, in my instance, the code segment 17, and then wherever I am in the, 17DA for the code segment, then a colon, and then the offset that I am in the file with that 100 hexadecimal byte header, accounting for the offset in the file. I know this is confusing. And then that next column over, is the byte composition of whatever particular opcode. And of course, that's always an even number of characters, because each byte is represented by 2 characters. So if it's a longer opcode, as we see, even real some at that call 02F3 at the top, that has, that's a 3-byte opcode for working with that address, that call to a particular address. Some like the pop DS, pop SI, pop BP, or pop BP, pop DX. Those are single byte opcodes, and you can see, and that, that the 1F or 5E or 5D, 5A, those 5 nines, those are all the opcode instruction. That's actually the machine language for the x86 CPU. That's what that means for all those CPUs that are even derived from that. They use that x86 code. Well, that's what it is. So in this case, I wanted to get to that segment to show what we need to modify. Now I'm going to do this a single line at a time to go through. And as I say, I've got my notes on the clipboard. But going through, and the first I'm going to do is I'm going to do an E, and then do even the lean 0. You don't have to, and it's good to double check myself to make sure, but I don't have to do necessarily that leading 0. I'm doing it just for the explanation that of people understanding the address that I'm modifying. Now, it has ultimately the byte at 02C6 is B0, and I'm going to replace that with 2C. Whenever I do the enter command, it says, hey, put what I type in there at that location. Doesn't matter what is in there previous, but it puts it at that location. And when I press enter, I'm going to do the next byte. And I could have gone through and I could have used that a period as a shorthand for the next sequential byte. But in this case, I'm typing out as 2 separate entries. The next byte of 02C7, I'm putting the value of 64. And of course, debug always works in hexadecimal. So once I press enter for that, so that has effectively replaced those 2 bytes. And I'm going to go through, rather than, I'm going to start the unassembly listing again, just to scroll all the way back down to where we're at, to that 02. Okay. So you can see now for that 02C6, it's got instead here now that subtract AL64. Subtract the value of 64 hex from what's in the AL register, and it's actually the year that's displayed within that location. So you're modifying the value. You're changing how that ASTCLOCK.com displays the year. And we're going to go through, and now whenever it hasn't acted to write the changes back, and it knows the name of the file that we're working with here. I could go through and I could issue the write command, write, the W-R-I-T, W-R-I-T-E, excuse me, to write that back to the hard drive, and it would know what the name of the file is. But we're going to go through and we're going to give it, just to be kind of a little bit more comprehensive here, we're going to say the name that we're going to do is ASTCLOCK.new. Now, it's important to note that that ASTCLOCK.mod is effectively a copy of the earlier AST clock. We're not actually going through. It's unmodified in this case. We're choosing a new file to write this to. And also, debug keeps track of that file size. Remember I said 2,557 bytes long. So if I were to do to change or to write a particular size of file, I would have to tell the system what the file size is. And that is by what is a combination of for extremely large files, of what is in the BX and being the most significant, and CX registers. Here, that file size is all able to be noted within the CX register itself. And debug does keep track of that, because if I do RCX, it lists that 09FD. And of course, debug always works in hexadecimal. And so you need a calculator. That's one thing. You can go to your Windows 10 system like this. And if you go through and put that, you have to set the calculator in Windows 10 or whatever, Windows 7, to the programmer and function. You just go up to I think it's under the file menu, and you select or a view menu that you want to view it as a programmer calculator. And it opens up the octal, binary, and hexadecimal translations or values of a number that's put in there. If you if you select the decimal field, put in the decimal number of 2557, you look up the hexadecimal conversion is this 9FD. And so debug has kept track of the size of the file. I could go through there and I could type in, that 9FD, but if I was changing the size, it'd even be where I could add on bytes onto that file. And that is the later example that was on that topic was, hey, I modified version 1.10, but there's a lot more code that I had to add on to the end of the program. Those steps were far more intricate, and that different file size would have to be specified in that instance. If I just press enter, it's going to go through and it's understand that I'm working with that file. The file that I want to write to disk is that 9FD size. It can't help to double check that and make sure that debug is on the same page of information that you want to do. As I say, if you leave the value just blank and you press enter, it goes through and understands, hey, that value's fine. And I do a W command, and I've already specified the name of the file that I want to write, but W is writing that file to the drive. And it tells you it's writing the 009 FD bytes. And then we're back to the debug dash prompt again. And of course, a very important command for debug is Q for quit. Okay. So if we go through and do a directory listing for ASTCLOCK dot asterisk, which is a wildcard, means any extension, file name of ASTCLOCK at any extension, any file name extension, we have that ASTCLOCK, ASTMod, and ASTCLOCK.new. And as it is, again, remember that ASTCLOCK.mod still has the same date and time as the original because it is not modified. We wrote to a different file. So this is a little bit more of an explanation of some of the debug commands, I guess is the way to say it, for what they do, or the file when it's written. Now that ASTCLOCK.new, it's got the current time and date because we just created that file basically of what the file image was in memory that we worked with and changed and patched. So I wouldn't necessarily have to rename the ASTCLOCK.com necessarily. I already have a copy of it, but it's the same way. We can do ASTCLOCK.com to ASTCLOCK. And I'll have to even see, this is our backup copy. This would go through, we've got even a few files of that file name with different extensions at this point. I want to give it a wildcard. Okay. And you notice, that ASTCLOCK.back has the same date and time, of course, as the original ASTCLOCK. Now I have to see for the DOS version I have. In fact, let's go through and check that. MS-DOS version 6.2. So when I go through and rename, it should actually prompt me. .new, okay, to ASTCLOCK.com. It should warn me that it already has a file by that name in the same root directory here. Okay, so we would have to go through, and it just kicks me back out to the DOS prompt. So we'd have to go like just a delete ASTCLOCK.com. Okay, so now if we do a directory listing of ASTCLOCK.wildcard, we've got the backup file that we did. We've got the mod, which is actually the same contents. And then we have that new. So we're going to go through and we're going to rename ASTCLOCK.new to ASTCLOCK.com. Okay. So we do a directory listing of ASTCLOCK.wildcard. There is our files now. And of course, that ASTCLOCK.com now has, today's date and effectively the time that was created. We're going to do a Control-Delete just to do a reboot. I want to see how I'm doing on time. Just under 40 minutes. And did a lot of a debug primer and a little bit of a DOS primer as it is too. So what we can see when AST clock started this time on boot, it says it's 03/15/22. It has that year, the last 2 digits of the year, 2022, in there correctly for this particular version of 1.21. And being it effective the latest version of AST clock, but I've not now gone through and patched it to be able to display the year correctly, thanks to that topic at the Vintage Computer Federation forum. So always good to kind of keep an eye out there and understand when you experience a problem, see what others have found out there and released. This worked out to be a good instance where I did a different route, and I mean they showed the debug sequence for that version 1.00 of going through and patching it, but I showed how to go through and to patch for that 1.21 version, and I think laid it out a little bit more, and of course on a forum. And I'm not discounting the description and things like that of what was done. I showed it in some more detail, I guess, in some areas. And you have to realize that some of the readers at the Finnish Computer Federation forum, they're going to have more knowledge. They may understand certain sequences, but then there's going to be the newbies that may only understand a portion or need it spelled out a little bit more. There even is some comments on that topic of, hey, I tried this and it didn't work for me. How do I need to do it? And there's some fairly detailed. That's why I'm going to have it in the video description of it. It's a good read to understand some of the things that AST Research did with those boards, with the driver and the earlier setclock.com and the sequence that need to be ran, and then what segment need to be specified to make that program resident on the system too. So that's just I'll go through and show by the DOS date command. It shows it as a 4-digit year. Just again, that was just how the AST clock program displays the year, not necessarily of what was in effect. It goes through there and it didn't know how to react to the year 22 being in that field, that year field, and so it would default and just display 99 all the time. And with that patch, then it says, hey, understand that we're past the year 2000 and go through and modify the contents of how that year is displayed and put it in there. So I think this has been a good descriptive video for that, informative enough. And if you enjoyed it, go ahead and click on that like button, please. And by all means, subscribe to my channel if you've not done so already. There's a lot more videos in the mix coming up. We're going to probe it even for this AST clock of what I/O addresses and things like that it has for that real-time clock chip as comparison to like the PS2 Model 30. So it's going to be, some real technical details that are going to be studied more. But I thought that this was a good video just on that single subject of somebody going through and seeing that prior video of mine and saying, hey, why does that AST clock say 99 on it? And he was talking about patching it or making it better. Well, that is what we did here. So this is IBM Museum. That's all I have for now. Thank you.